Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be discussing on the topic salts, and we are going to be looking at the different types of salts, and then we are going to look at the rules of solubility, that is the solubility in water, and then using those concepts that you're going to learn, we're going to do a few questions. So let's start. So when it comes to salt, salt is an ionic compound formed when the cation from a base combines with the anion derived from an acid. So this is a salt. You hear us talking about salt, especially when we are reacting acids with other compounds. We always say it forms a salt and other compounds like hydrogen or water. So this is when a cation from the base combines with the anion derived from the acid. And this case is it can be the hydrogen, or it can be sometimes it can be fully combined with the hydrogen ion or partially. So a salt is therefore formed when the hydrogen ions in an acid are replaced fully or partially or directly or indirectly by a metal or ammonium radical. So when you react, for example, a metal or an ammonium radical with an acid, it replaces all the hydrogen ions or partially all the hydrogen ions. Whatever compound that you form is referred to as a salt. The number of ionizable or replaceable hydrogen in an acid is usually called basicity of an acid. So when the hydrogens that are replaceable in an acid usually form a certain type of a salt. But now when you look and consider the different types of acids that are available, we have the monobasic acids. These are the acids that have one hydrogen. So it has one hydrogen. And then we have diabasic, which have two hydrogens, and we have tribasic, which have three hydrogens. These are the ones that can be replaced. So we have in monobasic, we have hydrochloric acid, nitric acid, and this is methanoic acid, and then this is ethanoic acid. And then diabasic, we have sulfuric acid, sulfurous acid, carbonic acid, and ethanoic acid, methandioic acid. And then tribasic, we have the phosphoric acid. So let's next go to the different types of salts. We have first normal salts. Normal salts is salts that they don't contain any replaceable hydrogen atom in them. So some of the examples are like sodium chloride. You can see this is sodium that has reacted with hydrochloric acid and has replaced the hydrogen fully or wholly. So the salt that is formed is refers to as sodium chloride. This is just a normal salt with no hydrogen atom. We have potassium sulfate, we have potassium carbonate, we have calcium nitrate, and the rest. They're usually neutral in state, in aqueous state. And then we have acid salt. Acid salt is formed when part of the ionizable hydrogen in an acid is replaced by a metal or metallic or ammonium radical. So when you talk about acid salt, part of the hydrogen has been replaced. So it's not fully replaced like in the case of normal salt. So for example, you can have for example, sodium, hydrogen carbonate. You can see it has reacted with carbonic acid, but it has not fully replaced all the hydrogen in the acid. And then we have the basic salt. These are the salt that contains hydroxyl ions. In the presence of hydroxyl ions is the one that is responsible for its basic properties. And you hear the word basic when they're being discussed. So we have for example basic magnesium chloride, basic lead carbonate. You can see it has the OH. We have the basic copper 2 carbonate, basic zinc chloride. It's here. So those are the different types of salt. We still have a few more. We have also other salts called double salts. These are the ones that have two different anions and or cations. For example, like hydrated potassium aluminium sulfate, you can see we have two cations in this case. We have potassium and aluminium. And another example is hydrated iron 2 sulfate. So we have the iron, and then we have the ammonium and sulfate, which are two radicals or anions in this case. And then we have trona, which we are going to discuss in carbon and its compounds. It has sodium carbonate and sodium hydrogen carbonate, of course, plus a few molecules of water. We have also other types of salts referred to as complex salts. These are the ones that have a metal ion at the center, and you're going to discuss this in details later on in campus, especially if you focus on chemistry. Example are tetraamine copper 2 sulfate, tetraamine zinc 2 nitrate, tetraamine copper 2 nitrate. We are also going to mention a few salts, complex salts in high school. First, you mention it in doing when you're doing uh, qualitative analysis, and we are talking about ammonia and sodium hydroxide reacting with some cations. So we are also going to mention those complexes, and also when it comes to nitrogen and its compound, you talk about also some complexes. So those are the different types of salts. And then some salts usually undergo hydroscopic, deliquescent, and efflorescent process. So what is these processes? Hygroscopic salts are usually those that absorb water from the atmosphere but do not form any kind of solution. So for example, we have anhydrous copper 2 sulfate, anhydrous cobalt 2 chloride. You notice this when we were discussing tests for water and hydrogen in Form 1. You can go and check that video out. We have the liquescent salts. These are the ones that absorbs water from the atmosphere and forms a solution. And some examples of the liquid salts are like sodium nitrate, calcium chloride, sodium hydroxide, magnesium chloride. So when these salts are exposed to the atmosphere, they usually absorb the moisture and then they form a solution. See the difference between hygroscopic salts and the liquescent salts. Hygroscopic do not form a solution, but they do absorb water from the atmosphere. The liquescent salts, though, absorb moisture and form a solution. And then we have efflorescent salts. These are the ones that now lose their water of crystallization in the atmosphere. And for example, we have sodium carbon decahydrate, and then we have iron 2 sulfate, heptahydrate, sodium sulfate, decahydrate. These ones, when you expose them into the atmosphere, they lose their water of crystallization. Some of them are in powder form, so even when they lose their water of crystallization, they still remain. But there might be a change in the color, but most of the time there is not much change in color. So those are some of the processes that salts usually undergo. So next, you're going to look at solubility of salt. It is important for you to remember these rules for solubility of salt. It's going to really matter a lot, especially when you're going to be discussing on qualitative analysis and doing the paper 3 section of form 3 work. It is important to remember them. So first of all potassium, sodium, and ammonium salts are soluble in water. I mean all. So that is oxides, hydroxides, nitrates, sulfates, phosphates, all sorts of potassium and sodium and ammonium salts are soluble in water. And then all nitrates are soluble in water. There is no exception. But when it comes to sulfates, there is an exception. All sulfates are soluble, but we have an exception with barium and lead. So barium sulfate, lead sulfate do not dissolve in water, and calcium sulfate is lightly soluble in water. And then all chlorides are soluble in water, except we have two exceptions, lead 2 chloride and silver chloride. And lead 2 chloride is unique. It is usually insoluble in cold water but soluble when hot. This is one of the questions that usually comes with qualitative analysis. So take note of that and make sure you can remember. All carbonates are insoluble except for group 1 metals and ammonium of course salt. So in the same case, you see we are repeating potassium and sodium. We know also we have lithium in group 1. So their carbonates are usually soluble. The carbonates of aluminium and iron do not exist. And then the oxides of calcium and magnesium are usually slightly soluble. And remember, we mentioned this when we were discussing Form 1 reactions of metals in water. And then potassium and sodium oxides are soluble. Of course, we said all sorts of potassium and sodium are soluble. The oxides of zinc, aluminium, lead, iron, and copper are insoluble in water. Ammonium oxide does not exist. And then potassium and sodium hydroxides also are soluble in water. The hydroxides of calcium and magnesium are slightly soluble in water. And then the hydroxides of all other that are remaining, that is zinc, aluminium, iron, lead, and copper, are usually insoluble in water. So next, now we're going to look at a few questions that are relating to what we have just discussed. So give the name of each of the processes described below which takes place when salt is exposed to air for some time. So anhydrous copper sulfate becomes wet. So it means that anhydrous copper sulfate absorbs moisture from the atmosphere and forms a solution. So we called this the liquescent. And then magnesium chloride forms an aqueous solution. It's the same deliquescent salt. Fresh, let's look at that one more time. So anhydrous copper sulfate becomes wet. It doesn't form a solution. This is hygroscopic. And then the magnesium chloride forming an aqueous solution is the one that is deliquescent. And then fresh crystals of sodium carbonate, you can see it's decahydrate, becomes covered with white powder of the formula sodium carbonate, now with one molecule. You see it has lost 9 molecules of water into the atmosphere, so this is an efflorescent salt. And then calcium oxide can be used as a solid drying agent for some laboratory gases. Explain. So what happened? Calcium oxide absorbs moisture from the atmosphere, and in this case it can absorb moisture from gases that are being dried. That is the reason why it's usually used as a drying agent. It is that ability of it to absorb moisture. So in an experiment, the following solids were provided to from 3 students. We have calcium nitrate, sodium hydrogen phosphate, basic magnesium chloride, um, ion, ammonium sulfate with 6 molecules of water. They were told to dissolve the given solid in differently in 20 ml of water, classify the given salts accordingly. So calcium nitrate is a normal salt. This is normal. We said it's normal because you can see there is no hydrogen. It has replaced it fully. Then sodium hydrogen phosphate. This is going to be acidic salt. You can see there is a replaceable hydrogen that is not fully replaced. It's partially. And then this is going to be basic because you can see the OH. And then this is going to be double salt because you can see it has 2 anions. And that's it. I hope you have been able to understand, and especially when it comes to the rules of solubility, make sure you can be able to remember those rules well before you finish the session. So see you in the next session as we look at methods of preparing different salts. See ya.